What is up? This is Dragon Slayer, and I am streaming live on Twitch. What is up? Right, I've got some feedback here. Right, sorry about that. Right, so today we're doing a little something different. I want to knock this out before I get to my regularly scheduled stream. This is CodinGame. It's the gamification of game programming, right? So basically, this is a website that teaches you how to program games. It's pretty outstanding. I remember doing this a few years ago. Never really got too far with it, but hey, bored, give it another try. And this is kind of the pretty much the easiest one you can do, right? This is like the starter for everybody. Although the community success rate is 63%. I'm not sure what that means exactly. Does that mean only 63% have tried it, or I'm not sure, or 63 or 100%, or is this 63% of the people who tried it, but only 63% actually passed it? I'm not sure. I don't know exactly what that means. But let's get to a couple notes here. Right, I'm going to be doing this coding challenge in C#, but there are numerous available languages for you to use. So let's dive in. First off, I'm going to do the kind of bottom-up solution, how you might approach this from the bottom up without a plan, right? Right, let's go ahead and clear this. Right. So yeah, I mean, I certainly prepared for this, but so as you can see, it gives you some rules here. And let's just go ahead and run it and see what happens. Right, we see Thor moving in this direction. His goal is to get to Mjolnir, his hammer, right? Or to reach the light of power, whatever. Right, so your program must allow Thor to reach the light of power. Right now, Thor walks from here down to here. Let's take a look at the code. Again, this is in C#. You can select different languages. I'm not sure. Or you can do light or dark. Who doesn't like the dark side theme, right? I mean, if you're not using that, are you even really a programmer? Yeah, the options for switching language used to be in this menu. I don't know. Well, they've changed it at some point, right? But there, I guess you'll just have to trust me. There is, oh no, here, they've got in a pull down menu now. So here's kind of your list of languages it supports. You can try this in C++. You can try this in Java. You can try this in JavaScript. And as you can see, not the same freaking thing. Not the same language, all right? You can try this in Python 3 as opposed to Python 2. You can do this in Bash. How about that? If you want to learn how to do Bash, you can do it in C. I don't know. I've never even heard of this language. Clojure. Seems kind of cool. Dart. Haven't used that. F#. I've heard of that. I don't know it, but yeah, there's that. Go, which seems to be a new popular language, right? Groovy, Haskell for your logic, right? Kotlin, which is what Google's new language that they want to use, as opposed to damn Java, although it still, uses Java. Okay, good job. Lua, good old Lua. Nice scripting language there. Objective-C for you Apple fanatics. I'm not sure what OCaml is. Pascal for you old people. Perl, same. Ditto. And you got Ruby and PHP, Rust, Scala, Swift, and VB.NET. Let's see. I'm familiar with C#, C++, Java. I know a little bit of Python, C, and VB.NET. I know all those pretty well. Well, okay, I don't know Python all that well. Not as well as these three, but, and C, of course. And, of course, Bash. You know, I'm sort of know that, right? Worked with DM Linux. You probably know a little bit of Bash. Pretty cool that you can use Bash for this. Anyways, so get back to what I know really well. That's C#. Of the languages I know, probably most up to date with C#, then C++, then Java. So there you go. That's how I'm rolling right now. All right, so let's get to the coding. Again, I'm going to give you the solution kind of from the bottom up, and then we'll look at it from the top down as well. So what I mean from bottom up is we're just going to try to go through the test cases and see if we can get it working. All right, we're going to start with the straight line test case. So pretty easy, right? Okay, so this is set up for us. That gives us some starter code. So we got variables, integer light y, integer light x. Okay, that is the position of the light. And we have initial tx, initial ty, and that is the initial spot, or that's where Thor starts. Okay? And then we have the game loop. So while true, just kind of a shorthand, right? While true, the integer remaining turns. So the remaining turns is going to be, or is represented as your energy, essentially. And that's what it's going to show up as when you're looking at this screen. And then where we come in, basically, here, what's Thor doing? Okay, so in order to get Thor move, you write console.writeLine and give it a direction. So in this case, the initial code tells him to travel to southeast. And you'll notice when we start, Thor's going southeast. Okay? If this is north, this is south, right? It's got a little compass there for you so you know what's going on. All right, so the idea is we want him to go in a straight line. We want him to go from his starting position straight east to the light. Okay? And that's relatively easy. All right, so let's get rid of that. Let's get our comments in here if we can. Now, you can use your own code editor if you want. There's an app to let you use your own code editor and then bring it into here. I'm not going to bother with that. I don't need code completion, so whatever. All right, so move Thor in a straight line east. Right, now if I can spell. And so, real simple. Oops, right line and east. Right, so what happened there? Why didn't it work? Well, it gives you, oh, hey, look, it even tells you. You didn't put a freaking semicolon in, guy. My favorite bug right there. Syntax error. All right, so here we go. And boom, we have solved the test case. Too easy. All right, what's the next test case? We want them to move up. All right, well, that's not going to work. So, all right, so now we need, this is a little more difficult. At the end of this, we're going to need to pass or have code that will pass all the test cases. So we could write console.writeLine.north to pass the up test case, but then we wouldn't be able to pass the straight line test case. So we need to have some selection, right? Again, I'm doing the bottom-up solution. We'll get to a top-down solution soon enough. Okay, so we're going to do if let's see. If initial tx, okay, if Thor's initial coordinates are, let's see, we're going to do, let's see, Thor's position. Let's go back here. And we want to make sure, okay, Thor's position is 5-4, the light position is 31-4, so we're looking to get him to move to the right. So if the initial tx, or initial Thor's x coordinate, is less than the light x, right, then console dot write line east, right? Because that's the direction we want them to move in. Right, let's test the code so far. Hey, it works. All right. Again, this is the bottom-up solution. Too easy, right? Booyah. Right, so next test case, we need him to go up. And right now, he's not going anywhere because his x is the exact same as the light position. So we need to throw in an else if. Initial ty is what? Greater than the, okay, we're looking at the numbers here. His starting position is at 17, so we want to get to 4. So if his initial ty is greater than, which it is, 17, then the light y, which is 4 currently, then console.writeLine north. Right? All right, so we have an ARA, and I can see it already. Again, syntax error. Let's see, do we have anything else? Nope. Here he goes. So we are able to pass this test and this test. And again, the kind of bottom-up solution is you kind of test it out until you get it right. Right? And this is the way it's kind of set up with the test cases. You start with the easiest test case, move up to something a little more difficult, then the next one gets a little more difficult, so on and so forth. So, next test case is the easy angle. right? So he's not moving anywhere because he is less than, or his initial x is greater than the light x, and his initial y is less than the light y, as you can see. So yeah, again, his x is 31, which is greater than light y, which is 0, and his starting y is 4, which is less than the light's y, which is 17. All right, so we need some more logic here, right? Give us another else if the initial ty is less than light y, and initial, actually we should probably do this in order just to make it look nice, is greater than light x, and the initial ty, Thor's y, is less than light y, then we'll move southwest. Right? All right, well, this should get him moving in the right direction, right? Right, well, it's moving southwest, but he's not going to make it. Oh, where? The world's doomed. Thanks, guys. Oh, let's see. See what it says. If you're colorblind like me, you might not be able to see that red print, but it says, failure. Thor wandered off the path and died. Invalid position. Right. So why is that? Right, let's try to get him just to go west, right? If see, else if initial tx is greater than light x, console.writeLine west, right? And we'll give them some south directions. Else if initial t y, so we can go down, is less than light x, or light y, sorry. And we'll send them console.writeLine south. It does have some autocomplete in there for you if you want to use it. Don't forget our freaking semicolons. Yes, this is C#, not Python, right? Right. So, let's see what happens now. Again, this is the bottom-up approach. We're just testing things out to see what happens, right? initial, not initial, initial. All right, let's try that again. Right, so it's moving west. Ooh, went too far, right? Right? He went too far and he didn't go in the right direction or the direction we wanted him to go. So we're doing better with this statement. So let's figure out why this statement didn't work. Let's put it at the top. Okay. Let's check again. Actually, let's check to make sure the rest of our code still works. Yeah, that works. Yeah, that works. All right. And this still doesn't work. And that's what we got to figure out. Why doesn't this work? Should work. The logic looks pretty good. All right, so let's find out why this isn't working. All right, so in the notes here it says write an action using to debug, console.error.writeLine with your debug messages. So let's get a debug message in there. Error dot writeLine. The value of initial ty is plus initial ty. So we're concatenating the value on the end of this string, right? And so every time it's going to show us what the value is. Okay, so as you can see, Thor's position is changing. His y position is changing, but the value of initial y is still 4. So that's why this logic isn't working, because the initial ty is always less than the light y, right? The initial tx is always less or always greater than the light x. So it's never going to go in this direction when we get down to this border here, right? When we get down to light y's position, it's just going to keep going south. It's going to keep going y or going down because the initial y is always less than, right? It's always going to be less than. So, how do we fix that problem? Okay. Well, as it turns out, you can put code anywhere in this code. You don't have to contain your code just to the while loop, right? Although we could. It's probably a good idea to just declare this locally. It's not a bad plan, right? So we will declare the local variable Thor's integer Thor x, and we will assign it. No, that's not what we want. Okay, so if you want to keep the when you declare variables, you want the scope to be as small as possible, right? Or as local as possible. That's not going to work for this particular variable. We want to assign the value initial tx to Thor's initial value. Hold on. Let me just go ahead and do it. I'll shut up for a second. Okay, so we're going to declare this up. Declare Thor's initial positions or position. All right, and so, or declare variables to hold. Right. So we're going to have Thor X equal to initial TX. We'll initialize it to the initial position. Okay. And Thor Y equal to the initial, or assign to, we'll assign the initial TY to Thor Y. Okay. Now we can use these in the loop to keep track of the actual this information, Thor's position. That's what we want. We don't want to constantly compare this to the we don't want to constantly compare the initial TY to the light Y. We want to compare Thor's actual Y at the time to the light Y, right? So, right, we're going to change this to Thor X and Thor Y. Right, I'm already running over. I'm supposed to be starting another stream here at 1200, but just bear with me. Get through this, and then I'll go on to playing X-Wing. So X-Wing is going to normally start 1200 on Fridays. It is Star Wars Friday, but we're working on this CodinGame stream, and so we'll knock out X-Wing as soon as we're done here. Probably another half hour left on this, right? Just kind of want to go through it. I could have made this a 10-minute video, just give you a straight up answer from the bottom, from the top down, but is that really how programming works, right? This is more like how programming works. You go through a bunch of bottom-up solutions until you finally figure out, hey, there's a better solution. You can get a bottom-up solution that works. It solves all the test cases. Too easy. And we're going to get there. But then, if you use some planning, right, you can come up with a far more efficient solution. So we're going to show you that too. Too easy. Let's keep going here. All right, so now we've changed this value here, Thor X and Thor Y. As it stands now, it's going to do exactly the same thing because we're not changing Thor X or Thor Y yet. Okay, well, it might. Thor X, Thor Y. What, did I spell something wrong here? The name Thor X does not exist in the current context. All right, so, of course, in C#, it can't guess what your variable is, right? So you gotta append it with integer. Make sure the C# knows that you're declaring an integer variable. It doesn't guess. This isn't Python. It is, you gotta provide the type. Sorry. Right, so let's try this again. Right. Actually, let's try this again, but let's change this variable. Thor Y of Thor Y. Okay, so now we have the debugging code in. It's been changed, so we can see what the value of Thor Y is as we run through this. And as you can see, the value of Thor y is 4. It's not changing. So we need it to change. Too easy, right? So whenever we get into this logic, we're going to go ahead and increment our variable. Increment Thor y. Okay? Thor y plus plus. You can use some C plus code there, right? It's not C plus, it's C plus plus. This is why, because it's increments. And this is the same as saying Thor y is assigned the value of Thor y plus 1. That's what it's saying. Okay? So let's go ahead and try this again. See what happens. Okay? As you can see now, we are incrementing each time. So when it hits the logic, now it's just going to go to the left. Boom. Problem solved, right? Yay! We solved the problem. Again, this is the bottom-up solution. Right, let's try this again. Alright, so now we're just moving east because we don't have the logic to handle southeast yet. Right? Right. Okay, so we're going to add in another else if. And this one's going to say if Thor X is less than, less than light X, and Thor Y is greater than, no, we also want to do less than here, right? Less than light Y. We're going to, again, increment Thor Y. Is assigned, no. Okay, well, I'll show you. This is the Thor Y plus plus is the exact same as doing Thor Y plus 1. Okay, and then we're going to go ahead and console dot writeLine and give it the appropriate direction. We want to go southeast. Too easy. Now we should be good. Right, moving southeast. Again, we don't have any console error writeLine because it's not hitting this logic. It's going straight into this logic. And we've solved it. Boom. So we play all test cases. And we're good. So let's go ahead and put in some notes here. This is the bottom. This is. Okay, just put my name. Dragon Slayer bottom up solution to Power of Thor, Episode 1. Power of Thor, Episode 1. Okay. Right. Logic passes all test cases. All right, so we've developed logic that passes all the test cases, but would it pass anything else, right? And we don't need some of this. We just need the else. We can delete this. Right? But, and it is efficient. I mean, it's only 4 ifs, right? But it doesn't do much else. Right? It wouldn't be able to pass, say, if we threw in another test case, moving a straight line to the west, it's not going to pass that. But let's just make sure we're good. Oops. No, apparently I did need some of that extra code. So we can do it in 6 lines, right? Right. All test cases. Okay. What is not efficient? This is the bottom up. A bottom up solution. So there's 2 types of design, right? There's bottom up design, which involves blind test cases. You're blindly testing out solutions, hoping that something will work, and you take the one that finally works, right? And then there's top-down solutions, right? You know what works, you develop a plan. In this case, we want pseudocode, right? And you develop something that's more efficient, right? Something that's intelligently designed. That is top-down design. Top-down design involves plans. You've already gone through all the bottom-up solutions, and you've not only gone through those, you've found something even better, right? Okay, so let's go ahead and submit that. Okay, and come back to this. Now we're going to do the top-down solution. So let's go ahead and clear. Okay, so now we are back to Thor moves to southeast. And does not pass the first test. Doesn't pass any test. Because he sucks. And the world's doomed. Right? That's what it says. Failure. Thor wandered off the path and died. Wah. Right? So, what do we need to do to make a top-down solution? Well, fortunately, they provide you with a plan. Okay? So here's the pseudocode. Right? I guess we could take a look at these things as well. Yeah, these are important hints. But here's, no, yes. here is the pseudocode. Let's go ahead and just grab this whole thing. All right, so now we have the pseudocode. So the first thing they want you to do is, it's probably easier to read from the hints. Okay, so here's a possible solution to the puzzle, right? You assign the value Thor X to initial TX. We already figured that out. Figured out this part. And then while true, do the following. Okay, read remaining turns. We don't have to worry about that. That's given. And then it's it's declaring direction X and direction Y and assigning it close quotes or empty quotes, right? So direction X will be empty quotes, direction Y will be empty quotes. Then, okay, we have 4 statements here. We have 2 if statements, an if, and then an else if, and then another if and an else if, right? A little bit shorter than what we did, right? So if Thor Y is greater than light Y, then assign the letter N to the string variable direction Y. And you do have to declare it. That's one thing, it's not including the types in here, but you do have to declare it. This isn't Python, but, well, this pseudocode would work for Python, though, right? Oh, you could probably throw it straight in and it would work. Just kidding. All right, so direction Y, you assign the string north. Thor Y, you assign Thor Y -1. So then Thor will travel north. And in the case of going south, Thor Y is less than light Y. Then direction Y is assigned south. Thor Y is assigned Thor Y +1. End if, right? So that's the end of our first if statement. Then for the east and west, we're going with Thor X greater than light X. Then direction X is assigned west. Thor X is assigned Thor X -1. Else if Thor X is less than light X, then direction X is assigned east. Thor X is assigned Thor X +1. So we've pretty much done all this, except we don't have, in the current code, we don't have a variable for the strings. We're just writing it straight into the console write line, right? But the advantage of assigning this into strings is that we can then concatenate. So then we'll do console write line or console.write line, direction Y plus direction X. So in the case of going north, we'll have direction Y, we'll have north, and direction X, which will be an empty string. And since these are inside the loop, these will reset to empty strings each time through the loop, right? So in the case of north, it's going to be direction Y will be north and direction X will be empty string. In the case of northeast, or let's say southeast, in the case of southeast, direction Y will be south and direction X will be east, right? So this is the solution then. We'll go ahead and write this out in code. So first things first, declare variables for Thor's current position. And we've got Thor X equals, or is assigned, or we will assign Thor X initial TX, and Thor Y is initial ty. Oops. Again, we are declaring these outside of the loop because we don't want them to reset to initial tx and initial ty every time through the loop, right? So within the loop, let's get rid of all this code. Don't need it. Okay, we're going to declare. Oh, we already made a mistake too. Look at that. We did not provide the type. Gotta watch that in C#. So declare string variables to hold the direction. All right. So we're going to have direction x. So what we're doing, yes, direction x. We should append this. It's a string, direction x equals empty, an empty string. We don't want it to, we want to start the value at the default, which would be empty. So string direction y equals right. All right, so we've declared those variables. Let's go ahead and open this completely up so we can see. Oh, let's see. What is going on up front, noob? And thank you for joining us in chat. And let's see. All right, so next thing to do is to start our if statements. So if Thor x is greater than is greater than light y, right? We're going to assign direction y, the value, the string value equals string value north, and then we're going to decrement Thor y. And we'll go ahead and do it this way, just for by example. Thor y equals Thor y minus 1. Too easy, right? Else if Thor x, Thor y, sorry, making logic errors already. It's not going to help. Thor y greater than, there's less than light y. Then direction y is south. Right. And we increment Thor y plus plus. A little shorthand there. Same thing as the statement above, except instead of decrementing, we are incrementing, right? Then that is the end of the first if statement. Let's go ahead and put some notes in here. This logic handles north and south. This logic handles east and west. So if Thor X is, again, it's nice having a plan, right? If you have a plan, you can just write everything out. You don't have to do any testing because you've already figured out what you're supposed to do. That's the point of having the plan, right? If Thor X is greater than light X, then direction is west, direction X is west, if I could spell, equals west, and we do what? We decrement Thor X, oopsie, syntax error. Else if Thor X, so we got another syntax error in there. Thor X is less than light X, direction X equals east, right? And Thor X plus plus. There we go. Notice in our last one we had our console write lines in each of the if statements. This time we're waiting until the end to put the console write line in. So console dot write line console.writeLine direction Y plus direction X. Too easy, right? Direction Y, which is your north and south, plus direction. It's going to be either north, south, or empty, and direction X is either going to be west, east, or empty, right? Depending on the logic. Now this is a lot. It's not only is it easier to read, it makes more sense, and it can handle all the test cases plus pretty much any test case you're ever going to throw at it, right? You can put this anywhere and put this guy anywhere, and this logic is going to handle all the test cases. So let's see. Boom. Play them all. Yep, it did it. So, again, notice the difference between the bottom-up design and the top-down design. Now, granted, you're probably not going to get to top-down design before you go through all the bottom-up designs, right? Because you're not going to have that understanding, that comprehension needed in order to create a solid plan like this, to create some solid and efficient logic like this. You've got to go through a whole lot of bottom-up design before you can get to something that's like this, right? Or before you have to have all that bottom-up, all those competences you learned from bottom-up design to get to the comprehension that you need in order to write something like this the first time, right? And this is the essence of programming. And when you're starting out, everything's bottom up because you're just learning. You're learning the competences you need in order to solve the problems, right? Eventually, you get to the point where you can actually solve some things from the top down, solve some problems from the top down, and make really nice, great code like this using this, a plan, creating your code beforehand with pseudocode, right? Let's see, so we'll call this Dragon Slayer Slayer's top down solution to Power of Thor, Episode 1. Yep, there you go. Put another comment in there. Concatenate and write the direction variables. Boom. Nice to have comments. Comments matter. I mean, really do. Right, before you can submit it, after you make changes, before you can submit it, you gotta make sure it plays all test cases before you can submit. So, done that, you're gonna go ahead and submit this. All right, so there it is. Finished it up. This is what your code should look like. If you're doing a top down, we already looked at what a possible bottom up solution would look like. And then this is just one of many possible top down solutions. You can look at other people's solutions. There's plenty of them that have been submitted to CodinGame. Outstanding website. Highly recommend it. Follow me, Dragon Slayer, on CodinGame, as well as here on Twitch. And we'll no doubt do this again next week. This has been a test run for this. I mean, it's technically gaming. It's the gamification of game programming. Teaches people how to program games, essentially, right? It's a great lesson. Very nice. Nicely done, CodinGame. Outstanding. So, thank you, Twitch viewers. Appreciate y'all. Next up is X-Wing after a short break. So, Dragon Slayer out.